Welcome, everyone. For decades, we believed we understood the shape of our home galaxy. Every textbook, every classroom model, every elegant spiral image told the same story. The Milky Way stretches 100,000 light-years across. That number became a fact, a fixed point in the language of astronomy. It was printed on charts, whispered in documentaries, written in exam questions. It was comforting, consistent, settled. Until now, something extraordinary has happened. The tools we built to explore the distant universe have turned inward, pointing toward our own galactic backyard. And what they found changes everything. The Milky Way, our cosmic home, is not what we thought. It is larger, heavier, and far stranger. In fact, new measurements suggest it could be twice as wide as every diagram ever drawn. This is not a small correction. It is not a rounding error. It is a complete redefinition of where we live in the universe. For 70 years, we have been drawing the map wrong. We were living inside a galaxy of unimaginable scale, and we had no idea. The revelation began quietly. Scientists noticed strange inconsistencies in their data. Stars that moved too fast, clouds of hydrogen extending beyond the expected boundaries, faint streams of light where none should be. For years, they dismissed these clues as noise, as mistakes, as artifacts of imperfect instruments. But the evidence kept growing. Then came a new generation of eyes. The Gaia spacecraft began measuring the precise position and movement of over 1 billion stars, while the James Webb Space Telescope peered through the dust that blinds ordinary light. Together, they revealed a truth no one could ignore. The Milky Way does not end where we once drew its edge. It keeps going, fading gently into the dark, extending far beyond what we can see. The implications ripple through every branch of astronomy. It changes how we measure our galaxy's mass, how we predict our collision with Andromeda, how we understand the role of dark matter, even how we estimate the number of worlds that might harbor life. This single discovery rewrites our cosmic address. Imagine standing in the middle of a city trying to map its borders. Buildings block your view, lights dazzle your eyes, and every direction looks the same. You cannot step outside to look back. That is humanity's problem. We are inside the galaxy we are trying to measure, trapped among its stars, blinded by our own perspective. For generations, we trusted the view we could see. But the truth was hiding in the darkness, in the faint halos of stars and gas invisible to ordinary sight. The instruments we built to gaze at distant galaxies accidentally uncovered the secret of our own. The Milky Way is not a modest spiral drifting quietly through space. It is a colossus, a giant wrapped in layers of unseen matter. And once this revelation came, it raised a haunting question. If we were wrong about our own galaxy, what else are we wrong about? How many other galaxies are larger, heavier, or older than we thought? What hidden structures fill the universe, waiting for sharper eyes to reveal them? This is not just the story of a bigger galaxy. It is the story of how science corrects itself. How discovery begins not with certainty, but with doubt. It is a reminder that every time we think we have mapped the universe quietly grows around us. The next time you look at the night sky, remember that those tiny points of light belong to something far vaster than the human mind can truly grasp. Every star, every shadow, every unseen thread of dark matter is part of a structure, stretching hundreds of thousands of light-years farther than we once dared imagine. This is where our story begins, not with the discovery of a distant world, but with the rediscovery of our own. For almost a century, astronomers believed they had the Milky Way figured out. They drew its neat spiral shape, measured its arms, labeled its center, and declared its size with confidence. The number was printed so often it became scripture. 100,000 light-years across. Teachers recited it. Students memorized it. No one questioned it. But the universe does not care about our confidence. It only waits for us to see it clearly. The mistake was simple, and yet profound. We tried to measure our galaxy from inside it. Imagine standing in the middle of an endless forest, trying to draw the shape of the woods. You can see trees, but not the edges. You can count trunks, but never know where they end. That was humanity's situation. We were lost in the middle of the Milky Way, surrounded by stars so thick that they blinded us to everything beyond. Early astronomers did what they could. They mapped the brightest stars in every direction. When the number of visible stars began to thin, they declared that to be the edge. 100,000 light-years became the magic boundary. It looked clean, precise, comforting. But galaxies do not end neatly. They fade. They scatter. Their stars thin into wisps and streams that stretch into the void. Our tools at the time were crude compared to what we have now. Telescopes could only see visible light, and much of the Milky Way's body is wrapped in dust that hides its true form. The galactic center, where the structure becomes densest, was completely invisible. Whole arms of the galaxy were hidden behind curtains of interstellar gas. We saw only fragments and assumed they told the whole story. For decades, scientists noticed inconsistencies. The speeds of stars at the outer rim didn't fit the expected pattern. Clouds of gas extended farther than the supposed boundary. Satellite galaxies orbited too far away to be fully explained by the Milky Way's known mass. Each puzzle piece hinted that something was off, but the data was never complete enough to prove it. Astronomy, like all science, builds on layers of assumption. When the first generation of measurements was taken, the methods seemed sound. Later astronomers refined them, but no one questioned the foundation itself. They improved precision, but not perspective. The map of our galaxy became a beautifully detailed illusion. Then technology caught up with our curiosity. Space-based observatories changed everything. Gaia began tracking the movement of over 1 billion stars with exquisite precision. James Webb opened windows through dust, revealing structures we had never seen before. Radio telescopes mapped clouds of cold hydrogen stretching far beyond the supposed galactic edge. The new data didn't just suggest a mistake. It shattered the old model completely. It turned out that what we had been calling the Milky Way was only its bright inner skeleton. Beyond it lay a vast halo of faint stars, gas and invisible matter extending twice as far, maybe more. The galaxy didn't stop where the light ended. It continued deep into darkness, wrapped in a gravitational shell so enormous that it redefined what it means to be part of our galaxy at all. The realization was both exhilarating and unsettling. For generations, we thought we had drawn a border around our home. But in truth, there are no borders in space. The edges we imagine are only artifacts of limited vision. The Milky Way fades into its surroundings gradually, its influence stretching out for hundreds of thousands of light-years before finally surrendering to the emptiness between galaxies. Scientists began to ask themselves hard questions. If we could be so wrong about something as close as our own galaxy, what other errors might hide in our cosmic maps? How much of the universe exists beyond the reach of our instruments? How much of what we call fact is only a shadow of the truth? The problem was not negligence. It was perspective. We had built our understanding from the inside, like fish describing the shape of the ocean. And when we finally found a way to look beyond our immediate surroundings, the scale of our mistake came into focus. The galaxy we thought we knew was merely the visible surface of a much grander, invisible whole. For the first time, humanity began to glimpse what the Milky Way truly is. Not a clean, bright disk floating in space, but a sprawling, diffuse empire of stars, gas, and dark matter stretching farther than imagination can easily grasp. And yet, this revelation was only the beginning. What followed was an even deeper investigation into the hidden architecture of our home, the invisible skeleton that holds it together, and the mysterious force that shapes every orbit, every stream, every spiral arm. The revelation did not come all at once. It arrived in fragments, in quiet numbers whispered through data streams from space. At first it seemed insignificant. A few stars moving faster than expected, a handful of clouds stretching beyond their supposed limits. But as the readings accumulated, a pattern began to take shape. The edges of the Milky Way were not edges at all. They were horizons we had mistaken for walls. The Gaia spacecraft became the key. From its vantage point beyond Earth's atmosphere, it measured the positions and motions of over 1 billion stars with breathtaking accuracy. Each point of light became a coordinate in a cosmic map. Every star's motion told a story, of orbit, of gravity, of distance. When scientists plotted these stories together, the outlines of the Milky Way began to change. They discovered rivers of stars flowing through the outskirts of the galaxy, long, thin trails known as stellar streams. These streams were relics, the remains of smaller galaxies that the Milky Way had consumed over billions of years. The streams acted like tracer lines, marking the reach of our galaxy's gravitational pull. And what they revealed was astonishing. The Milky Way's influence extended twice as far as we believed. The James Webb Space Telescope added another layer. Its infrared vision pierced the dense clouds of dust that had hidden much of the galaxy's structure from view. Where older telescopes saw darkness, Webb saw crowded fields of stars, clusters, and filaments stretching outward into the halo. It was as though a veil had been lifted, and the Milky Way's true shape had finally come into focus. Meanwhile, radio telescopes across Earth began mapping the distribution of neutral hydrogen, the most common element in the universe. This gas emits faint radio signals that can travel through dust, allowing astronomers to trace the hidden arms of the galaxy. What they found defied expectation. The hydrogen extended far beyond the visible disk, curving outward in immense arcs that wrapped around the galaxy like invisible ribbons. One by one, the pieces aligned. The stellar streams, the hydrogen maps, the new star counts, all pointed to the same conclusion. The Milky Way was at least 200,000 light-years across, possibly more. We had underestimated it by half. The implications were staggering. A galaxy twice as wide is not just a larger shape on a map. It means double the stars, double the gravitational field, double the potential for worlds and life. It means the universe itself might be denser and more interconnected than we imagined. Scientists struggled to contain their excitement and disbelief. How could we have missed something so enormous? The answer lay in our blindness. We had built our picture of the galaxy from what we could see, the bright spiral arms and the glowing core. But most of the Milky Way is invisible, composed of dark matter and faint stars scattered like cosmic dust. We were measuring the galaxy's skeleton, not its body. The discovery also raised profound questions about dark matter, the mysterious substance that outweighs normal matter by a factor of 10. The motion of stars in the outer regions only made sense if the galaxy was wrapped in an enormous halo of unseen material. This halo extended far beyond the visible boundaries, holding the galaxy together like an invisible hand. When researchers combined all the new data, Gaia's precise star maps, Webb's infrared imaging, radio telescope surveys, and satellite galaxy orbits, a clear picture emerged. The Milky Way is not the medium spiral we imagined. It is a heavyweight, a giant rivaling Andromeda itself. Its total mass might exceed 4 trillion times that of the Sun. That realization changed more than the numbers. It changed our story. For generations, astronomers thought of the Milky Way as a modest neighbor in a quiet corner of the universe. Now it appeared to be a cosmic titan, vast, complex, ancient, and powerful. Its gravity reaches deep into the space between galaxies, shaping the orbits of dozens of smaller companions. The moment the final calculations were confirmed, a silence fell over the research teams. It was not the silence of confusion, but of awe. Every familiar image of our galaxy, the neat spiral in textbooks, the glowing disk on posters, suddenly felt too small, too simple. We had been living inside an empire of stars, surrounded by structures so immense that only now, after centuries of observation, could we begin to trace their outlines. And as the data continued to pour in, it became clear that this was not merely a story about size. It was about the unseen framework that holds galaxies together, the hidden forces that shape everything from star formation to the fate of worlds. The discovery of a larger Milky Way was the first step into a much deeper mystery, one that reached beyond light, into the dark foundation of the universe itself. The instruments had shown us the shape of the invisible. But the question now was even bigger. What exactly was this unseen matter that defined our galaxy's true form? And how could something we cannot see or touch control everything that we can? Science advances not by certainty, but by measurement. Every great discovery begins with a mismatch between what we expect and what we observe. The Milky Way's hidden vastness was no exception. It began with a simple question that refused to go away. Why were the stars at the edge of our galaxy moving too fast? In theory, objects farther from the galactic center should move more slowly. The farther out you go, the weaker the pull of gravity. That is how it works in our solar system. Mercury whirls around the Sun in just 88 days, while Neptune drifts lazily through its orbit in 165 years. The pattern is precise and predictable. Gravity weakens with distance, and speed decreases accordingly. But when astronomers measured the rotation of our galaxy, the curve refused to fall. Stars on the outskirts moved almost as fast as those near the center. It was as if some invisible hand was keeping them tethered, refusing to let them drift away. At first, scientists assumed there must be hidden stars or unseen gas clouds contributing extra mass. But no matter how much visible matter they added to their models, the numbers did not match reality. Something more was there. Something that did not emit light, could not be photographed, and yet exerted gravity strong enough to hold billions of stars in orbit. They called it dark matter. Dark matter does not shine, reflect, or absorb light. It does not interact with electromagnetic radiation in any measurable way. To every telescope, it is invisible. And yet it outweighs everything we can see by a ratio of 10 to 1. The universe we know, the stars, planets, nebulae, galaxies, all of it is the thin skin on a far larger, invisible structure. When astronomers began to account for this hidden mass, the picture of the Milky Way changed. The visible galaxy, the spiral arms, the glowing core, the bright clusters, made up only a fraction of the total. Surrounding it was a massive halo of dark matter, a spherical cloud extending hundreds of thousands of light-years beyond the visible edge. This halo explained everything. The strange stellar velocities, the far-flung satellite galaxies that refused to drift away, the gravitational pull stronger than light alone could justify. The Milky Way was not merely a disk of stars. It was a vast, invisible sphere, with the bright spiral we see embedded like a jewel inside. To confirm this, scientists turned to the motion of satellite galaxies, the smaller systems orbiting the Milky Way like moons around a planet. By measuring how fast these companions move, researchers could infer the total mass required to keep them bound. The faster they orbited, the more massive our galaxy had to be. The results were clear. The satellites were moving far too quickly for the old mass estimates to make sense. To hold them in orbit, the Milky Way needed to be not just larger but immensely heavier. The final calculations suggested a total mass of roughly 4 trillion suns, most of that mass unseen. This realization transformed our understanding of what galaxies are. For centuries we imagined them as islands of light floating in darkness. Now we know the opposite is true. The darkness is the structure. The light is decoration. The stars are only the visible tips of an enormous gravitational iceberg. Dark matter acts like an invisible scaffolding, shaping galaxies as they form, guiding how stars and gas collect. Without it, the Milky Way would not exist. Its spiral arms would have flown apart long ago, its stars scattered into intergalactic space. We owe our very stability to something we cannot see. Even with this knowledge, dark matter remains a mystery. Scientists have proposed many theories about what it could be. Exotic particles, hidden forces, or something entirely new in the laws of physics. We have built detectors deep underground, hoping to capture a passing particle. But so far the dark remains silent. Still, its fingerprints are everywhere. We see its gravitational pull bending light from distant galaxies. We see its presence in the motion of stars, in the shape of clusters, in the slow dance of galaxies across the cosmos. And within our own Milky Way, we see it defining the boundaries of everything we know. The invisible halo extends perhaps 200,000 light-years, maybe more. Beyond that, its density fades gradually, blending into the dark between galaxies. There is no sharp edge, only a slow surrender to emptiness. For astronomers, this discovery redefined more than just one galaxy. It changed how we think about the universe itself. If every galaxy is wrapped in a massive dark halo, then the universe is not mostly empty space at all. It is a web of invisible matter connecting everything. Galaxies like beads on unseen threads, drifting through a cosmic skeleton that gives the universe its shape. The Milky Way's vastness, its hidden mass, and its dark foundation are not just curiosities of measurement. They are clues to the deepest structure of reality. The more we uncover, the clearer it becomes that what we can see is only the beginning. But every discovery opens new doors. A larger galaxy means a stronger gravitational reach, and a stronger reach means our neighboring galaxy, Andromeda, is closer to us. Not in distance, but in destiny. The revelation of the Milky Way's true size forces us to reconsider one of the most dramatic events in our cosmic future: the coming collision between two giants. When the numbers finally settled, and the models stopped changing, the reality was impossible to ignore. The Milky Way was far bigger than anyone had imagined. It wasn't just a correction to the textbooks. It was a shift in the story of existence itself. Every equation built on the old scale now had to be rewritten. Every prediction about our galactic future had to be recalculated from the ground up. The most immediate consequence lay 2.5 million light-years away, where our sister galaxy Andromeda drifts silently toward us. For decades, astronomers predicted that the two galaxies would collide in about 4.5 billion years. It was a comforting distance, safely beyond the lifetime of the Sun. But those calculations assumed the Milky Way was smaller, its gravitational reach shorter. The new measurements changed that. A larger galaxy means a stronger pull. A stronger pull means the dance between the Milky Way and Andromeda began long before we realized. Their halos, vast clouds of dark matter and stars, are already reaching toward each other, stretching invisible fingers across the void. Some scientists now believe the outermost regions may already be touching. If that is true, the collision has technically begun. The first stage will be slow, silent, and invisible. The dark matter halos will merge long before the galaxies themselves collide. Gravity will begin to distort both systems, pulling stars into long trails, stirring the space between them. Over the next few billion years, the process will accelerate, and when the visible disks finally meet, the night sky will transform. To anyone alive to see it, Andromeda will grow larger and brighter with every passing millennium. What begins as a faint smudge of light will swell until it dominates the heavens, a glowing arc stretching from horizon to horizon. Then, in an event beyond human timescales, the galaxies will intertwine. Stars will drift through each other like ghosts. Vast clouds of gas will compress, igniting waves of new star formation. It will be chaos, but not destruction. Despite the drama, almost no stars will collide. The distances between them are too vast. The chaos will be gravitational, not physical. Over time, the two spirals will twist together, their arms stretching into loops and bridges, their shapes distorting beyond recognition. After perhaps 1 billion years of this cosmic dance, they will merge completely into one massive elliptical galaxy. Astronomers have already named it Milkomeda, the child of two giants. But the collision isn't just spectacle. It changes our understanding of time itself. A larger Milky Way means the gravitational interaction starts sooner, maybe in 4 billion years, maybe less. For humanity, that means the future sky has already been rewritten. The show begins earlier than we thought. The discovery also doubles the number of stars within our galactic boundaries. That number matters more than you might think. Every star is a potential sun. Every sun may host worlds. Every world could be a cradle for life. For decades, scientists estimated the Milky Way contained around 200 billion stars. Now that number could exceed 400 billion, perhaps even more. If life is rare, even 1 in a billion stars, doubling the number of stars doubles the odds. Somewhere out there, orbiting one of those faint distant suns, another civilization might be looking back, wondering if they too are alone. The expansion of the galaxy's known size does more than change statistics. It reignites the oldest question in science. Are we unique? Or are we part of a far larger story? And then there are the smaller companions. The The satellite galaxies that orbit the Milky Way like moons around a planet. Their orbits, once thought temporary, now seem permanent. The larger gravitational field of the Milky Way holds them more tightly. Some of them are already being torn apart, their stars stretched into streams that wrap around our galaxy like ribbons. These cosmic scars tell the story of how galaxies grow, through collision and consumption. The Milky Way is not just a home, it is a predator, a survivor built from the bones of smaller worlds. Each of these discoveries reshapes our understanding of cosmic evolution. The local group of galaxies, once imagined as a quiet neighborhood, is now a dynamic battlefield of gravitational forces. The increased size and mass of the Milky Way mean that the space between galaxies is smaller than we thought. The universe feels more crowded, more connected, more alive. Even the timeline of cosmic history changes. If our galaxy is more massive, then its gravity has influenced nearby systems more strongly, pulling them into motion, bending light, altering the cosmic web. The foundation of astronomy, the distances, the ages, the interactions, all must be recalculated in light of this new understanding. But beyond the equations lies something more human. The discovery forces us to confront our place in the universe again. For a moment we thought we had found stability. We knew the size of our home, the path of our future, the boundaries of our world. Now those boundaries have dissolved. We are adrift in a galaxy twice as large, in a cosmos more complex than we dared imagine. The Milky Way is no longer a diagram on a page. It is a living, breathing structure evolving around us. Every light in the night sky is part of a grander pattern. Every unseen particle part of an invisible ocean that defines our existence. We are discovering not just where we are, but what we are made of. Fragments of ancient collisions, orbiting within a vast halo of darkness, moving toward a future written in gravity and light. The shock of discovery did not stop at the edge of our galaxy. Once scientists realized how wrong we had been about the Milky Way's size, they began to wonder, what if this mistake was not unique? What if every spiral galaxy in the universe had been underestimated in the same way? Astronomy depends on patterns. We compare the light from distant galaxies to the light from our own. We assume that what is true here is true everywhere. If our baseline was wrong, then our entire map of the universe might need redrawing. Researchers turned their telescopes outward again, armed with new tools and new suspicion. They examined Andromeda, our nearest galactic neighbor. For years, Andromeda was thought to be slightly larger than the Milky Way, spanning 220,000 light-years. But when astronomers applied the same updated measurement techniques, tracking stellar streams, mapping hydrogen gas, and accounting for dark matter halos, the numbers began to climb. 250,000 light-years, then 300,000, maybe more. The same pattern appeared everywhere they looked. Triangulum, the third largest galaxy in our local group, grew from 60,000 light-years to nearly 100,000. Smaller galaxies expanded too. The difference wasn't random. It was systematic. We had been measuring galaxies the same way we once measured our own, by light, not by gravity. We were drawing their edges where brightness faded, not where gravity ended. The correction reshaped everything. Galaxies turned out to be much larger, their halos more massive, their gravitational influence extending farther into space. The gaps between them shrank. What we once thought of as empty intergalactic space was no longer empty. Invisible halos of dark matter and faint stars overlap, connecting galaxies into vast networks. This discovery confirmed a growing suspicion among cosmologists. The universe is more crowded than we imagined. Galaxies are not isolated islands drifting through a sea of nothing. They are connected by filaments of dark matter, bound together in colossal webs that stretch across the cosmos. Every dot of light we see through a telescope sits at a node in that web, like dewdrops clinging to an invisible thread. With this new understanding, the universe itself began to feel different. Bigger galaxies meant more mass in total. More mass meant more gravity, and more gravity meant the cosmic expansion. The slow stretching of space itself might be slower than previously measured. If galaxies were undercounted or their mass underestimated, then the forces shaping the universe's fate might not balance the way we thought. It also forced astronomers to revisit one of the deepest questions in modern cosmology: the rate of the universe's expansion, known as the Hubble constant. Measurements of this rate have long been in tension. One method suggests the universe is expanding faster, another slower. The discrepancy has puzzled scientists for decades. But if galaxies are more massive than we believed, that tension might ease. Perhaps the difference isn't in the math, but in the map itself. The implications reached even further back in time. Distant galaxies, seen as they were billions of years ago, also appeared larger under the new analysis. That meant they formed earlier, evolved faster, and assembled into structures far sooner than our models predicted. The early universe, once thought to be a scattered collection of faint, small galaxies, might have been a place already filled with mature giants. The story of cosmic evolution would have to be rewritten. If galaxies were bigger, their collisions more frequent, and their halos more entwined, then the universe we see today is the product of a far denser and more violent history than we ever imagined. Every cluster of galaxies, every filament, every void, all of it must be reconsidered. And then there was the matter of missing satellites. Computer simulations predicted that a galaxy the size of the Milky Way should have hundreds of small companions orbiting it. Yet we had found only a few dozen. Astronomers called this the missing satellite problem. But a bigger Milky Way offered a simple explanation. Its gravitational reach extended farther, meaning many of its satellites orbit so far out that they had escaped detection. They were there all along, too faint and too distant to see, ghosts hiding in the dark. It was a humbling moment for science. The same instruments that allowed us to gaze at the edge of the universe had revealed that we still didn't fully understand our own galactic neighborhood. Every time we refine our tools, the universe grows larger and stranger. Even the cosmic web itself, that vast network of dark matter and galaxies, might be more intricate than we can perceive. Our telescopes see only the bright knots of light, but simulations suggest the true structure is far more elaborate, stretching for billions of light years in every direction. If this new vision of the universe is correct, then what we thought was the grand design of creation is merely the visible fraction of an invisible whole. The cosmos is not a void with scattered lights. It is a solid lattice of gravity and mass, glowing faintly where matter condenses into stars. And if we have been wrong about scale, we may also be wrong about time. Larger galaxies, forming faster and merging earlier, suggest that the universe reached complexity sooner than we thought. The first stars, the first black holes, the first worlds, all may have appeared earlier. Their light already ancient when our own planet was still forming. Every discovery ripples through the rest of science. If galaxies are bigger, then distances are smaller, and the universe itself may be younger than we believe. Our cosmic calendar might be off by hundreds of millions of years. The realization that we might have misjudged not just the size of the Milky Way, but the entire universe, was both thrilling and unsettling. It meant that even now, after centuries of observation, we are still climbing the first steps of understanding. The map keeps unfolding faster than we can draw it. In the end, the lesson was simple, but profound. Every time we think we've reached the edge of knowledge, the universe expands. Every time we define the boundaries of what is known, those boundaries dissolve into mystery. The Milky Way's newfound size was not just a discovery about one galaxy. It was a reminder of the cosmic principle that defines all science. The more we see, the more we realize how much we've missed. For centuries, humanity has tried to make sense of its own smallness. Every age believed it stood near the center of the universe, until the universe reminded us otherwise. We once thought Earth was the center of creation. Then we discovered the sun. We thought the sun was the heart of all things. Then we found the Milky Way. We thought the Milky Way was the universe itself, until the galaxies appeared by the millions. Each revelation pushed us further from the center, further from certainty, but closer to truth. The new discovery about our galaxy feels like the next step in that same ancient pattern. We have learned, once again, that what we thought was the whole story is only the first chapter. The Milky Way's true size and hidden mass don't just change astronomy, they change perspective. When you realize your home galaxy is twice as wide, you feel something shift inside. The numbers, 200,000 light-years, 4 trillion solar masses, are so vast they dissolve meaning. Our minds cannot hold them, but we try anyway. We imagine the light from one edge taking 200,000 years to reach the other. We imagine every star a potential sun, every sun surrounded by unseen worlds, every world spinning under its own sky. And for a moment, we feel the enormity of where we are. We live inside an empire of stars, and yet most of it is invisible. 90% of the Milky Way's mass is dark, unreachable, untouchable. We move through it every second, surrounded by oceans of matter that pass through our bodies like ghosts. It is humbling to realize that the world we experience is only a small portion of what exists. We are creatures of light living in a universe of shadow. That thought can feel lonely, but it can also feel liberating. Because in that vastness, in that mystery, we find meaning. The more we discover, the more we understand that ignorance is not failure. It is the beginning of wonder. Science is not the conquest of knowledge. It is the art of realizing how much remains unknown. Astronomy, at its core, is an act of humility. It teaches us that perspective defines truth. From inside the galaxy, we misjudged its scale. From our small world, we mistook our own significance. The stars remind us that knowledge is not about certainty. It is about clarity, the kind that grows brighter as we admit how dark the universe really is. There is something beautiful in that. Every generation believes it stands on the edge of understanding, only to learn that the horizon stretches farther still. The map of the cosmos is never finished. It expands with every new telescope, every new question, every daring glance into the unknown. If the Milky Way is larger than we thought, then our story is larger too. It means there are more stars, more worlds, more possibilities. It means the stage of creation is bigger, the drama deeper, the mystery richer. Somewhere in that vastness, perhaps even now, another civilization might be looking up at their own night sky, wondering where the edges of their galaxy lie, wondering if someone else is asking the same questions. We are bound by the same ignorance, the same desire to know. In that way, the darkness that hides most of the universe also connects us to it. It is the great equalizer, reminding us that no matter how far we travel or how much we learn, we will always be creatures standing under an infinite sky, reaching upward. The Milky Way's hidden size is not just a scientific revelation. It is a philosophical one. It tells us that boundaries are illusions, that certainty is temporary, and that every horizon conceals another beyond it. And when you stand beneath the night sky and see that faint band of light, the galaxy itself seen from within, you realize that you are looking at the inside of an incomprehensible structure. Every spark of light you see is a point within a larger whole that stretches across time and space. The stars above are not distant. They are neighbors. You are inside the thing you are trying to understand. In that moment, science and poetry become the same. Both are acts of awe, both driven by the same impulse, to look outward and see ourselves reflected in the vastness. For all our instruments, all our equations, all our discoveries, the universe still refuses to fit neatly into our minds. It is too big, too old, too beautiful to be reduced to data. And maybe that is the point. The universe is not meant to be solved. It is meant to be experienced. So when we say the Milky Way is larger than we thought, we are not just talking about light years and mass. We are talking about humility. We are talking about rediscovering the scale of existence and our small but precious place within it. The stars have always been there, waiting for us to notice. We just needed better eyes and a little more patience to see what was right in front of us all along. The universe is always in motion, even when it feels still. The stars above us may look frozen, but every one of them is drifting through space at hundreds of kilometers per second. The Milky Way itself is not stationary. It sails through the cosmic sea, pulled and pushed by gravity on a scale too vast for human intuition. And at the edge of our galactic horizon, another giant is approaching. The Andromeda Galaxy, bright, spiral, immense, is falling toward us. We have always known it was coming, but now we understand the full gravity of what that means. For decades, astronomers predicted the collision would occur in about 4.5 billion years. That estimate came from the assumption that the Milky Way was smaller, its gravitational pull weaker. But with new data revealing a much more massive and extended galaxy, the timeline tightens. The slow dance between these two giants has already begun. Their dark matter halos, those invisible spheres of gravity, are reaching out toward each other right now. In fact, some researchers believe they have already touched the first contact in a merger that will define the next chapter of cosmic history. Though we cannot see it, the space between the galaxies is already alive with motion. Particles, stars, and gas clouds are feeling the subtle tug of the approaching giant. The future has already started. The first visible signs will come long before the actual collision. Over the next billion years, Andromeda will grow steadily brighter in our night sky. What is now a faint smudge of light in the constellation, Andromeda will expand into a glowing disk, clear even to the naked eye. Thousands of generations from now, the human sky will begin to change. As the galaxies draw closer, gravitational tides will distort both systems. The spiral arms will twist and stretch, flinging streams of stars into intergalactic space. Whole constellations will be reshaped. The familiar patterns that guided ancient travelers will vanish, replaced by new arrangements of light. When the galaxies finally meet, they will not crash like solid objects. Instead, they will pass through each other, stars sailing through stars, planets through planets, almost all avoiding direct collision. Space is mostly empty, but gravity will weave its chaos nonetheless. Tides will ripple through both galaxies, stirring their gas clouds, igniting new waves of star formation. For a few 100 million years, the night sky will blaze with newborn stars. The collision will not destroy the Milky Way. It will transform it. The elegant spirals will unravel, forming loops and bridges of light. The two supermassive black holes at the centers, ours and Andromeda's, will begin to spiral toward each other, releasing enormous bursts of gravitational energy. When they finally merge, they will shake the very fabric of space-time, sending ripples across the universe. Eventually, after 1 billion years or more, the chaos will settle. The two galaxies will fuse into a single, colossal elliptical galaxy. The spirals will be gone, replaced by a smooth, bright core surrounded by scattered shells of ancient stars. Astronomers already have a name for this future being: Milkomeda, a single galaxy forged from two. For Earth, the story is uncertain. By the time the merger begins, our sun will be nearing the end of its life. It will have grown larger and hotter, possibly rendering our planet uninhabitable. But if any descendants of humanity survive, perhaps on other worlds or in space itself, they will witness a spectacle unlike anything imagined. From their skies, Andromeda will grow until it fills the heavens. At its peak, it will stretch across the entire dome of the sky, a luminous river of light so vast it would outshine the moon. It will not be a moment of destruction, but of creation, the birth of a new galactic form. And yet, in a way, the collision is not an ending but a continuation. Galaxies have been colliding and merging since the beginning of time. It is how the universe evolves. Every great structure in the cosmos was shaped by such encounters. We are not witnessing a catastrophe, but a natural cycle, gravity's way of recycling matter into new forms. When the dust finally settles and the galaxies become one, the Milky Way's descendants will live inside a new structure, more massive, more luminous, and filled with fresh stars. The night sky of that far future will be different, but no less beautiful. Perhaps new worlds will form in the aftermath, orbiting young suns born from the debris of the collision. Life, if it endures, will adapt to this grand reshaping of the heavens. It is strange to realize that our galaxy's fate has already been written in motion. We live inside a story billions of years long, one that began long before Earth existed and will continue long after it is gone. The stars we see tonight are not fixed points. They are part of an immense choreography, guided by the invisible hand of gravity, moving toward a cosmic embrace that no power can stop. And if the Milky Way is larger and heavier than we once believed, that future becomes even more majestic. The collision will be fiercer, the resulting galaxy brighter, the waves of new stars even greater. Our galaxy's true size is not just a fact. It is a prophecy written across the heavens. We have always been curious about where we came from. Now we also know where we are going. The universe is not static. It is a living story, unfolding slowly, gracefully, beautifully. And in that story, our galaxy, vast, ancient, and expanding, is both the stage and the character. Even after all the discoveries, even after mapping billions of stars and measuring distances across hundreds of thousands of light-years, one truth remains unshaken. We still do not fully understand what we are made of. The Milky Way, for all its beauty and scale, remains a mystery. The discovery that our galaxy is larger than we thought only deepened that mystery. The more we uncover, the more we realize how little we know. Every new observation opens a door to another question. Every measurement reveals another layer of complexity. The cosmos seems to expand faster than our comprehension can follow. One of the greatest puzzles is the missing baryon problem. Baryons are the ordinary matter, the stuff that makes up stars, planets, and people. According to our best cosmological models, there should be far more of it in the universe than we can see. When scientists count all the atoms locked inside galaxies, stars, and gas clouds, they find only half of what theory predicts. The rest has vanished. For years, researchers suspected this missing matter might be hiding in the vast spaces between galaxies, too diffuse to detect. But recent evidence hints that some of it might actually belong to our galaxy, stretched across its enormous halo in thin, hot plasma. If that is true, the Milky Way is not just larger, but filled with unseen material glowing faintly in X-rays, too dim for the naked eye but massive enough to hold galaxies together. Then there is dark matter, the invisible scaffolding of the universe. We know it must exist because its gravity shapes everything we observe. But what it is remains unknown. It could be made of particles that barely interact with normal matter, or something entirely beyond our current physics. Some theories even suggest that what we call dark matter might be a new kind of energy, or the shadow of higher dimensions. We cannot prove it yet. We can only feel its pull. And beyond dark matter lies an even deeper enigma: dark energy. This mysterious force seems to be driving the expansion of the universe, pushing galaxies apart faster and faster over time. Together, dark matter and dark energy make up about 95% of everything that exists. That means all the stars, all the planets, all the galaxies, everything we can see, account for less than 5% of the cosmos. The rest is unseen, untouchable, and unexplained. Even the structure of our galaxy's core remains uncertain. At the center of the Milky Way lies Sagittarius A, a supermassive black hole 4 million times the mass of the Sun. For years, scientists believed it was quiet, dormant, slowly consuming stray gas clouds. But new evidence suggests it may have been far more active in the past. X-ray echoes found in nearby molecular clouds imply that Sagittarius A once flared brightly, releasing jets of energy that illuminated the galaxy like a beacon. We live in the calm aftermath of a sleeping giant. Then there are the stellar streams, the remains of smaller galaxies our own has absorbed over billions of years. They crisscross the halo like faint rivers of stars. Each one tells a story of cosmic violence, of smaller worlds torn apart by gravity and consumed by a larger one. Some of these streams are so faint that only with Gaia's precision could we trace their paths. Yet they are everywhere, proof that the Milky Way is still growing, still feeding, still changing. The more we study these structures, the clearer it becomes that our galaxy is alive, not biologically but dynamically. It evolves. It breathes in stars and gas and exhales radiation and dust. Its shape changes over time. Its arms twist and shift. Its stars drift farther apart. The Milky Way we live in now is not the one our ancestors saw. and it will not be the same for those who come after. Even time itself feels different on this scale. A single orbit of our Sun around the galactic center takes about 230 million years. That means since the dinosaurs walked the Earth, the solar system has completed only one lap through the Milky Way. Everything we know, every civilization, every discovery has happened in a blink of cosmic time. And yet, there are still deeper mysteries. How do galaxies first form from clouds of dark matter? Why do some grow into giants while others remain small? What determines their shapes, their lifespans, their fates? We can simulate their birth on computers, but the real universe is always more intricate, more unpredictable. Every discovery reminds us that we are only beginning to see clearly. We have mapped the stars, but not the space between them. We have measured gravity, but not fully understood it. We have found the fingerprints of the universe's hidden matter, but the hand itself remains unseen. In some ways, the Milky Way is a mirror. The more we learn about it, the more we learn about ourselves. We too are made of ordinary matter surrounded by mystery, luminous against a backdrop of shadow. We too are small pieces of something far greater, moving through space and time with only partial knowledge of what lies ahead. The search continues, not because we expect to finish it, but because curiosity is what defines us. The universe hides its secrets in plain sight, daring us to keep looking. And even though we may never uncover them all, the act of searching is its own kind of victory. The Milky Way still holds answers that could change everything. About physics, about creation, about the meaning of space itself. But to reach them, we must keep building, keep watching, keep wondering. Every question leads to another. Every answer opens a door. And perhaps that is the greatest mystery of all, that in a universe built from darkness, the brightest thing it contains is the desire to understand it. When we look into the night sky, we are not looking at the universe as it is. We are looking at the universe as it was. Every star, every galaxy, every faint shimmer of light carries the memory of a different time. Some of the light that reaches our eyes tonight began its journey before humanity even existed. It traveled for thousands, millions, even billions of years through silence and darkness, crossing the great void just to tell us that it was there. That single truth, that light takes time, means that when we look out, we are also looking back. We are witnessing history written in photons, and as our instruments grow more powerful, we are learning to read that history in ever finer detail. But the story it tells is always the same at its core. The universe is older, larger, and stranger than we believed yesterday. The discovery that the Milky Way is far bigger than we thought is just the latest reminder. It tells us that even when we think we understand our own home, there are still layers we cannot see. We live inside a structure so vast that it defies comprehension, a web of light and darkness that stretches across space and time. And yet from within this immensity, tiny beings on a small planet have learned to measure it, to name it, and to wonder at it. That might be the most extraordinary part of all. Not that the galaxy is vast, but that we can know it. That consciousness, arising from dust and carbon and sunlight, can reach beyond its own horizon and grasp the shape of the cosmos that created it. The universe became aware of itself, through us. Every discovery in astronomy carries a quiet echo of that idea. When the first telescopes were built, they showed us moons and planets. When the great observatories rose, they showed us galaxies. When we sent probes into space, they looked back and showed us Earth. Small, fragile, luminous. And now, as we build instruments like Gaia and James Webb, we are seeing not just the universe beyond us, but the invisible structure within which we exist. It is easy to feel insignificant when faced with such scale. 200,000 light-years, 4 trillion suns, numbers so vast they blur into abstraction. But insignificance is only one way to see it. There is another. We are small, yes, but we are part of something incomprehensibly beautiful. The same atoms that form our bodies were forged in the hearts of ancient stars, scattered across the galaxy, and gathered here to think, to feel, to dream. We are not separate from the Milky Way. We are its voice. Our galaxy is alive in the sense that it moves and evolves. It consumes and creates. It carries memory in the motion of its stars, and potential in the clouds where new stars are born. We are children of that process, shaped by the same forces that guide the galaxies. When we study the universe, we are studying ourselves. And still, there is so much left to learn. We have mapped less than a fraction of our own galaxy. We do not yet know the full story of its birth, its future, or its true nature. Somewhere in its distant halo, beyond the reach of our instruments, there are stars we will never see, worlds that will never feel the warmth of our sun, and perhaps even forms of life that will never know we exist. But that is the beauty of it. The universe does not need to be fully known to be wondrous. Maybe the point of discovery is not to reach an ending, but to keep the story going. Every generation pushes the frontier a little farther. Every new telescope sharpens the view, and every revelation, no matter how vast, becomes the foundation for the next question. That is how knowledge grows, not in leaps of certainty, but in the steady unfolding of curiosity. When future astronomers look back on our time, they will see this era as the moment when we began to see the invisible, when light alone was no longer enough, when we learned that the real universe is not just what shines, but what binds, the dark, the silent, the unseen. And maybe that lesson extends beyond science. The same is true in life. What defines us is not only what can be measured, but what cannot: hope, imagination, the quiet human need to understand. The cosmos around us and the consciousness within us are made of the same material, mystery wrapped in light. So, when you stand under the stars and see that soft band stretching across the sky, remember what it truly is. You are looking at the inside of a galaxy, a vast spiral of suns so wide that light takes hundreds of thousands of years to cross it. You are part of that. Every atom in you, every breath you take, every thought you have is part of that same structure. The Milky Way is not something you look at. It is something you are. We began this journey thinking we had found the edge of our galaxy. We end it knowing there are no edges. The Milky Way fades into the dark, and the dark fades into infinity. The boundaries we draw are human, temporary, fragile. The reality beyond them is endless, and perhaps that is the greatest discovery of all. That in a universe without borders, there is no final truth, no final map, only an ever-expanding invitation to keep exploring. The cosmos is not a question to be answered. It is a story to be lived, and we are part of that story. Small, luminous, curious, forever looking outward, forever asking what lies beyond the next horizon.